Hello everyone, so this is a mini lecture on straight lines and their graph. So the general form of the equation of a straight line is y equals mx plus c, where m is the gradient, which is a measure of the steepness of the straight line, and c is the y-intercept, which is where it crosses the vertical axis of the graph. So let's have a look at what a gradient of 2 means. So this line is y equals 2x. We can think of that as being y equals 2x plus 0. So it has a y-intercept of 0. In other words, the point where it crosses the vertical line is at 0. And it has a gradient of 2, which means if we turn the ramp into a staircase, it is characterized by this across 1, up 2, across 1, up 2 trend, and that is what a gradient of 2 means. So it's going across 1, up 2. So the gradient is how much it goes up by if we're going across 1. And if we think about a negative gradient, so here we've got a gradient of -2. That negative just means that this time, instead of going up 2 units, we're going down. So we've got across 1, down 2, across 1, down 2, across 1, down 2. But what about a fractional gradient? So here we've got a graph of y equals 4x over 3. So one way we can think of this is that if we go across 1 unit, we are going up 4/3 units. Or another way we can think of the same thing is the gradient is also called rise over run. So the rise is the change in y, and the run is the change in x. So if we look at what happens if we go with a run of 3, so in other words 3 units across, so from 0 to 3, we are going up by 4 units there. So 4 units up for 3 units across. Now, if we add a +2 onto the end of that, so that we now have a y-intercept of 2, what that tells us there is the point that it crosses the y-axis, which is that vertical axis, is at y equals 2. And it still has that same gradient, so this is still, even though we probably can't quite see it from the segment of the graph that's shown on screen there, it's still got that across 3, up 4 trend to it. So it's got that same gradient as y equals 4x over 3 that we had in the last page there. Now, here's an equation to find the equation of this graph. So we want something y equals mx plus c. We need to find the values of m and c here. So if we find m, which is the gradient, and we find c, we have our equation. Looking at that graph, the first thing that we notice is that we have a y-intercept of 3, so we can see immediately that the value of c is 3. So our equation is going to look like y equals mx plus 3. Okay, so we have our y-intercept. We just need to find our equation now, so we can also use one other value that the straight line goes through to find m. And then once we've got m, we have our equation. So one other point that it goes through, which is quite clear from the graph, is we have an x-intercept of 1. So that this is the point x is 1 and y is 0. Because this point is a height of 0, we are right on the horizontal axis there. So that means if we put in y equals 0 and x equals 1, we get 0 is equal to m multiplied by 1 plus 3, and therefore 0 is equal to, what's m times 1? It's just m plus 3, and that gives us, if we move the the 3 to the other side of the equation, we get m equals -3, and therefore your equation is y equals -3x plus 3. Okay, so we've got the equation of that graph. Now, a straight line passes through the point 3,1 and has a y-intercept of 4. What is the equation of that line? So firstly, we can see what the y-intercept is. We know that the y-intercept is 4, and that y equals mx plus c. So therefore, your equation is going to look like y equals mx plus 4. Okay, so we've got part of the equation. Just like with the previous question, we still need to find the value of m, so we still need to put the other point, which is 3,1, into our equation here. So we've got the point 3,1, which means x is 3, y is 1. If we substitute that in, we've got, so y is 1 equals m is unknown multiplied by x is 3 plus 4. So then we need to solve that equation for x. So we've got 1 is equal to 3m plus 4, and if we move that 4 to the other side, we get 3m equals 1 minus 4 is -3, and then if we divide both sides of that equation through by 3, we get m is -1. So our equation is therefore going to be y equals -1 times x plus 4. And 1 times x, we don't need to write a multiplication by 1, so we can even simplify that equation just down to y equals -x plus 4. But this particular question can be written even tidier as y equals 4 minus x. That's going to simplify it because that takes out the need to write a negative sign there. Okay, so now we have to find the equation of a straight line which passes through 2 points. So let's do that using the gradient formula. So m gradient is going to be the rise, which is the change in y's, which is y2 minus y1, divided by x2 minus x1. So change in the y's, which is the rise, divided by the run, which is the change in the x values. So here we have the y's is going to be, so 3 is y1, 7 is y2, so this is going to be y2 is 7 and y1 is 3, over, then we've got the x values, x2 is 4 and x1 is 2. So we've got 7 minus 3, which is 4, over 4 minus 2, which is 2, and we get 4 over 2, which is 2. Okay, so we have a gradient of 2, which tells us that our straight line is going to be y equals 2x plus c. So we don't know what the y-intercept is here, but just like what we've been doing with the previous questions, what we can do is substitute one of the points that you're given, which is either 2, 3 or 4, 7, into what we've got so far as our equation. And I think you'll agree that the easiest point to work there would be 2, 3. So x is 2, y is 3. So therefore our equation is y is 3 equals 2x, which is 2 times 2 plus c. So therefore we've got 3 equals 4 plus c. And therefore we've got c is going to be -1. And therefore your overall equation for this graph is y equals 2x minus 1. Okay, so y equals 2x minus 1 is your equation if you use this method to solve that question, which is to find the gradient using rise over run, or change in y's over change in x's, and then substitute a point in to get your y-intercept. But there's another way that we can do that same question, which is, let's approach this problem as a simultaneous equations problem. So what we're going to do here is we are going to substitute both points into y equals mx plus c initially. So we're doing the same problem as we did on the last page, just doing it a slightly different way. If we substitute the point 2, 3 into that equation, so x is 2, y equals 3, substitute that into y equals mx plus c, y is 3 equals m times x, which is 2 plus c, which is going to be our first equation. And if we substitute the other point into y equals mx plus c, so the other point is 4, 7, and here x is 7, x is 4, y is 7, so y is 7 equals m times x is 4 plus c, and that's equation 2. Okay, so we have a simultaneous equations problem. Let's just rewrite what we've got a little bit neater. Let's drop the time symbols. So our two equations are 3 equals 2m plus c, and we've got 7 is equal to 4m plus c. Okay, simultaneous equations problem from there, and we can proceed by either elimination or substitution. We notice that if we minus the two equations from each other directly, that is going to eliminate c. It will therefore give us just one equation with one unknown, so that's what we'll do. So we'll minus the two equations from each other. So top equation minus the bottom equation. So on the left-hand side, that's 3 minus 7, which is negative 4, equals 2m minus 4m plus c minus c. Well, that cancels out, so that's good. We have an equation that no longer has a c. So let's simplify. So we've got negative 4 equals negative 2m, and therefore m is equal to negative 4 divided by negative 2, which is indeed 2. Very good. That's consistent with what we had so far that's what we had on the last page, gradient of 2. So our equation is y equals 2 times x plus c. So far we are in complete agreement with what we found using method 1. And then we can sub m equals 2 into the original first equation, which was the first equation that we had was 3 equals 2m plus c. So 3 equals 2 times m. Well, m we've already found to be 2 plus c, so therefore 3 equals 4 plus c, and therefore c is negative 1, and our equation is therefore y equals 2x minus 1 is your final equation. Okay, and last question we're going to look at in this mini lecture is we've got an equation of a line which is y equals 4x plus 20, and we want to know what the x-intercept and what the y-intercept is. So when we're finding an intercept, we make the other letter equal to 0. So we'll start with the y-intercept. For the y-intercept, we make x equal to 0. And if we make x equal to 0 and substitute that into your equation, which is 4x plus 20, we get 4 times 0 plus 20, which is going to be 20. So a y-intercept of 20. And for the x-intercept, we need to make y equal to 0. So we've got 0 equals 4x plus 20. So if we move the 20 to the other side there, we've got 4x equals negative 20, and that means that x equals -5. Thanks for watching. Next comes the mini lecture on parabolas and quadratic graphs.